When facing a dispute with an electrical inspection, several avenues can be explored to reach a resolution. Firstly, contact the town's building department. Explain the complete situation to them. Emphasize that the initial rough-in inspection was approved by their authorized inspector from the approved inspection company. Inquire if they are willing to show some flexibility or offer an alternative solution. It's possible they might accept the final inspection from the original inspector, even though he's now with a different, unapproved company, considering the unique circumstances. Secondly, attempt to negotiate with the original inspection company. Reason with them, highlighting that the predicament arose not from any fault of the homeowner or the electrician, but due to their inspector leaving the company mid-project. Request a reduced fee for the final inspection. Argue that since their new inspector essentially performed a cursory check, rather than a complete re-inspection, the full fee is not justified. Thirdly, weigh the initial inspector's offer carefully. If the inspector offered to conduct the final inspection without any additional cost, consider accepting the offer. While his new company isn't on the town's approved list, his inspection can still offer valuable reassurance regarding the quality and safety of the electrical work. It could serve as an independent verification, even if it doesn't fulfill the official requirement for the certificate of occupancy. Fourthly, contemplate filing a formal complaint. If all other options are exhausted and you believe the inspector acted unethically, you can file a complaint against him with the state's licensing board or consumer protection agency. In your complaint, detail the sequence of events, emphasizing the inspector's initial approval, his subsequent departure, and the complications his actions caused. Be aware that this process might be time-consuming and might not guarantee a favorable outcome. It is important to consider several principal considerations. It's undeniably unfair for the homeowner to incur extra expenses because the inspector changed employers. The inspector, despite the change in his professional affiliation, had an obligation to fulfill his prior commitment to complete the final inspection. Both the electrician and the homeowner should actively advocate for an equitable resolution, ensuring they aren't financially burdened due to circumstances beyond their control. Maintaining a calm and professional demeanor throughout this process is key. Articulate the situation clearly, explore all possible avenues, and strive to discover a resolution that meets everyone's needs while upholding ethical standards. This is not about assigning blame, but about finding a fair path forward. Remember, electrical work is closely tied to safety. If the inspector performs something not according to the code, there are a lot of liability issues. You also need to consider that you're potentially liable for anything that happens at the house, especially if you are performing electrical work. When performing electrical work, make sure to disconnect power. If you are unsure of what you are doing, contact a licensed professional. Safety should be paramount. If you do happen to get shocked, seek immediate medical attention. If you are around water, make sure that you have ground fault circuit interrupters, or GFCIs, to protect against electrocution. It's understandable to be frustrated with additional costs or delays, especially when dealing with construction timelines and rental agreements. However, approaching the situation with a clear head and a focus on finding a solution will be more productive in the long run. Document everything, maintain records of all communication, and be prepared to present your case clearly and concisely when speaking with the town, the inspection company, or any regulatory bodies. Consider getting multiple quotes for inspection services so you can avoid these types of situations in the future. Having a backup plan and understanding the local regulations thoroughly is always a good idea. Remember, the goal is to ensure the electrical work is safe and compliant with all applicable codes, while also protecting the homeowner from unfair financial burdens. Regarding electrical codes, there is the National Electrical Code, or NEC. This is published by the National Fire Protection Association, or NFPA. The NEC is not law, but it is widely adopted by states and municipalities. It is updated every 3 years. It is a comprehensive set of guidelines for safe electrical installations. Firstly, the NEC covers general requirements. Chapter 1 of the NEC deals with the scope, purpose, and definitions applicable to the code. It outlines the types of installations covered and clarifies the intent of the rules. Secondly, wiring and protection are described. Chapters 2 and 3 detail the requirements for wiring methods, overcurrent protection, grounding, and bonding. These sections are crucial for ensuring electrical safety and preventing hazards such as fires and shocks. Thirdly, equipment and devices are discussed. Chapter 4 covers the installation requirements for various types of electrical equipment, including luminaires, appliances, and motors. It addresses issues such as spacing, support, and protection. Fourthly, special occupancies are covered. Chapter 5 addresses specific requirements for special occupancies such as hazardous locations, healthcare facilities, and swimming pools. These locations require additional safety measures due to the increased risk of electrical hazards. Fifthly, special equipment is included. Chapter 6 covers specialized equipment such as electric signs, elevators, and electric vehicles. It provides specific guidelines for their installation and wiring. Sixthly, special conditions are discussed. Chapter 7 addresses special conditions such as emergency systems, fire alarm systems, and communications systems. These systems require specific design and installation considerations to ensure their reliability and effectiveness. Seventhly, communication systems are covered. Chapter 8 covers communication systems such as telephone, television, and data networks. It addresses wiring methods, grounding, and bonding requirements for these systems. There are also tables and examples. Chapter 9 provides tables and examples to aid in the application of the code. These resources are invaluable for contractors and inspectors in ensuring compliance with the NEC requirements. The NEC contains numerous tables that provide essential information for electrical installations. For example, Table 310.16 specifies the allowable ampacities of insulated conductors rated up to 600 volts. This table helps determine the appropriate wire size for a given load, ensuring that the conductors do not overheat and pose a fire hazard. Another important table is Table 250.122, which specifies the minimum size of equipment grounding conductors for grounding raceway and equipment. This table helps ensure that equipment is properly grounded, minimizing the risk of electrical shock. The NEC also provides examples to illustrate the proper application of the code requirements. These examples are helpful for contractors and inspectors in understanding how to apply the code in specific situations. For instance, the NEC provides examples of how to calculate the load for a dwelling unit and how to select the appropriate overcurrent protection. Understanding and applying the NEC correctly is crucial for ensuring electrical safety. Contractors and inspectors should stay up to date on the latest version of the NEC and seek clarification when needed. Consulting with experienced professionals and attending training courses can also help improve their understanding of the NEC requirements. Grounding and bonding are critical for electrical safety. Grounding provides a low impedance path for fault current to return to the source, tripping the overcurrent protection device and clearing the fault. Bonding ensures that all metal parts of an electrical system are at the same potential, reducing the risk of electrical shock. When dealing with older homes, like the one built in 1860, it's especially important to pay attention to the grounding and bonding systems, as they may not meet current code requirements. The NEC requires that all electrical equipment be properly grounded and bonded to ensure safety. The grounding electrode system typically consists of a ground rod, a ground ring, or a metal underground water pipe. The equipment grounding conductor connects the metal parts of the electrical system to the grounding electrode system, providing a path for fault current to flow back to the source. Bonding is achieved by connecting all metal parts of the electrical system together with bonding jumpers. This ensures that all metal parts are at the same potential, reducing the risk of electrical shock. There are many types of wiring methods permitted by the NEC, including non-metallic sheathed cable, or NM cable, also known as Romex, metal-clad cable, or MC cable, electrical metallic tubing, or IMT, and rigid metal conduit, or RMC. Each wiring method has its own advantages and disadvantages, and the choice of wiring method depends on the specific application and the environment in which it will be installed. NM cable is commonly used in residential wiring because it is relatively inexpensive and easy to install. However, it is not permitted in certain locations, such as damp or wet locations. MC cable is similar to NM cable, but it has a metal jacket that provides additional protection. ENT is a thin-walled metal conduit that is commonly used in commercial and industrial applications. It is relatively inexpensive and easy to install, but it is not as strong as RMC. RMC is a thick-walled metal conduit that is used in applications where maximum protection is required. It is the most expensive wiring method, but it provides the best protection against physical damage. Overcurrent protection is essential for protecting electrical circuits from overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a predetermined level. Circuit breakers are reusable devices that can be reset after they trip, while fuses are one-time devices that must be replaced after they blow. The NEC requires that all electrical circuits be protected by overcurrent protection devices that are sized appropriately for the circuit. The size of the overcurrent protection device is determined by the ampacity of the conductors in the circuit. The ampacity of a conductor is the maximum amount of current that it can safely carry without overheating. The NEC provides tables that list the ampacities of different types of conductors. When selecting overcurrent protection devices, it is important to choose devices that are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories, or all. Listed and labeled devices have been tested to meet certain safety standards and are more likely to perform as intended. Always adhere to manufacturer instructions and local codes to ensure all work is compliant. When dealing with electrical inspections, communication is key. Maintain clear and open communication with the inspector, addressing any concerns promptly and providing all necessary documentation. This proactive approach can help facilitate a smoother inspection process and minimize potential delays.